first of all, I just want to say thanks for the amazing workshop and the great lineup of presentations that you guys put together. It's very interesting. It is very as well focused on the nighttime lights. Our presentation is a little bit different, I believe, because we are trying to focus more on an application domain of the nighttime lights. So generally, our angle into this from the beginning was try to create project analytics systems, and that would be for example, mining projects or resource projects, or even infrastructure projects. An industrial partner to our research, who I'm working there right now, Hatch, is a Canadian engineering firm, which was managing a big portfolio of different projects. And it was very important for us to create project analytics outcomes, like a framework that can help us assess the risks of these projects, kind of follow on them, and have a better handle on different aspects of them. And we divided the problem to three main parts, as within designing the intelligent system, to representation, learning, and inference. And within the learning side was where we realized that there could be a potential of capturing remoteness risks based on nighttime satellite imagery, which ended up to a paper that kind of led to my like our discussions with Alba Orbital later on. I'm very happy to be here and quickly review what we did and how we try to characterize that. So a little bit on the prevalence of remote project. This is a graph by Pryor, a study that he done in Australia. It shows that from mid-19th centuries to early 21st centuries, the average copper ore grade actually fell from 25% to 2%. That means that as the world is kind of depleting the like a better and more potent resources, we have to look forward to more perhaps remote resources that we can tap into. And one interesting observation here is that given this decline in the average copper grades, for example, and this is true basically for most of the commodities, the total amount of that we produce around the world of copper is keeping increasing, and that's because actually we are doing that. We are tapping towards more remote, inaccessible resources. And a major part of that is that remote resources, they have to be big enough to kind of pay for the cost of the infrastructure that needs to get there, for the cost of the, like they have to justify the big investments that goes into kind of making them accessible. And with that, there is a whole lot of investments on remote projects around the world, which and a study that was done on the effectiveness of such investments kind of resulted in a very, very poor and metrics comparing to the projects that are less remote. And all of this is perhaps common sense. The remote projects was shown to have suffered from cost overruns, schedule slippage, and operability problems for 30, 29, and 70% more, which is a high difference between these for this specific variable on definition of the project. And the important so the thing is that here what I wanted to say is that within the industry, within the projects industry, the way they categorize this remoteness is quite crude and coarse, in a sense that they divide it to three categorical, they divide it to a categorical variable with like three states of non-remote, remote, and semi-remote. And they come up with like very random justification for that. For example, they say If it is closer to 100 kilometers, we call it out to a city, we call it non-remote. If it is more than 300 kilometers, we call it remote. And anything in between, we call it semi-remote. So this kind of led us to think that, yeah, perhaps could be a better way of continuously and automatically categorize these projects. And we looked into nighttime lights quite extensively. We as Hatch, actually, we did a project in Pueblo Viejo in Dominican Republic from 2008, which I'm not sure if you guys can see that the Red Cross. The Red Cross has been the site of a very remote mine that kind of went through an intensive expansion from 2008 to 2012. And we saw that not only the location of the mine got lit, but as well some of the cities surrounding that position. And there has been, I'm aware of several other studies that done similar comparisons, which got us to a point to realize, to think of how we can do that remoteness quantification. Now, we were able to find a remoteness index of Australia that was published for 2011. And this is what you can see on the left. It's called ARIA, Accessibility and Remoteness Index of Australia, which kind of divided the whole remoteness range to a continuous variable from 0 to 15. And they actually calculate these by going into, like, taking census data, and then as well taking commercial data. They define some service centers around the different communities and calculate the relative distance of populations to those centers. And we kind of, when we looked at it, and then we looked at the nighttime lights of Australia, we thought, yeah, there is definitely some version of correlation there. And so I'm gonna quickly, and then we kind of defined the problem as a classic machine learning problem with the predictor variable and the target variable. For the target variable, we chose the ARIA, and for the predictor, we chose the average radius calibrated for 2011. We were lucky, because we had both for 2011, so we could kind of cancel out some of the errors that could have been there because of time differences. And the other aspect of the problem that we dealt with was that although the ARIA was published, was actually built as a continuous variable, what we had was a map of certain different regions, which only could help us to solve this problem as a classification problem, whether we can classify certain points within Australia as any of these regions. However, we did try that, but as well we did try another way, which that we thought that, okay, perhaps we can find the points on the borders of these categories, and then that would allow us to actually solve the problem as the regression problem and get to a continuous gradient of remoteness, which is what we did eventually and end up having actually better useful results. So the other thing that I was going to talk about within our feature engineering is that there is this law of geography that we learned about, which was very interestingly stated, that everything is related to everything, but within the remoteness, the concept of distance is of importance. So how we went about this was that we defined certain classes of features with certain radius of effectiveness around any point. That would be 100, 300, 500, and 1,000. And these, again, we chose them based on the significance within our model. And we masked out the seas and the open waters and tried to calculate the specific features of the intensity and the distribution of the night lights within that radius of effectiveness. So we got our features, we got our target variable, which was the Australian remoteness index. And then we actually built the model, tried to validate the model, and eventually calculated our remoteness index on the validated model for the whole continent of Australia, which ended up to match the area quite well. And this is, as you can see, this is what we call nighttime remoteness index NIRI for 2011 for Australia, putting on the same slide with the ARIA index. Now there is this is a little bit of the kind of performance of our models. We tried different types of let's say machine learning algorithms and different types of sampling methods. Eventually, we chose EARTH, which is a specific let's say implementation of a method called the multiple adaptive regression splines. The method called actually MARS, but since it is copyrighted name, so the code that is developed is called EARTH. So we use EARTH model and SVR, which is support vector machines, at the very end. And we did different types of cross-validation, including a geographical half-split test, which means that we trained our model based on the basically east side of Australia and tested it on the west side of Australia. And with the geographical split test, actually, we got into 0.84 coefficient of determination, which was actually quite surprising for us to see that, yes, although it sounds perhaps intuitive, but we kind of established that the nighttime lights can predict this. And this is very important because these indices, for example, they do one in Canada of these remoteness indices, which is where I am presenting today from. And they're very time consuming to calculate. They're very time consuming to collect because it is based on census and commercial data of services. And usually governments do this perhaps every 1 to 2 years. And our methodology can help, for example, to bridge the gap perhaps between those calculations, instances of calculation of the index, and as well as for projects and stuff for projects that are located on jurisdictions where there is no census data, or they are located in close proximity of like 2 different jurisdictions, which is hard to kind of map stuff like that to come up with the risk method. Now, this is a little bit on the model tuning that we used with both EARTH and SVM. It shows the basically parameter tunings, which I can talk about it if there was interest later on. And then the next thing that we did was that we thought, okay, we have the 2011 right now for Australia. However, that was the time actually where VIRS suit results data actually was published. I believe it was for the first time. It was in 2018 or something like that. So we thought that, okay, this is pretty good because right now we can use the same model to basically calculate, to get the remoteness indexes for Australia in 2015. Although totally different types of sensors, but our index is quite comparative in nature because we normalize it both. We normalize both our features, and as well we normalize based on the geographic context of the continent, for example, or a country. From 2011, with the first, I forgot the acronym, the first nighttime lights, and 2015 with the VIRS, we saw a big expansion on this northwest part of Australia, which was kind of expected because during that time there was a whole lot of industrial activity going on there, a few very, very large projects going on there, which is actually as well shows an angle that our index could show that perhaps ARIA or other remoteness indices cannot, because these are perhaps mainly more, this is the mining region of Australia, Pilbara, and they are mainly more industrious in nature of the economic activity there. There is not much established population in cities and all that. And that's why the ARIA, for example, categorizes this as a remote. However, if your angle to this is the risk of remote projects is perhaps less remote than what a census-based index would provide. We did this for North America and Canada. We got the chance to actually check this as well with the Canadian remoteness indices that I mentioned for 2015. And we as well were correlated with Canadian remoteness indices with the correlation factor of 0.84. Now, in terms of how we use it right now, this is the map of like a NIRI map of Northern Ontario and Quebec. The star points is actually the mining areas, the mining camps within Northern Ontario, the main mining ones, which is actually helping us to define a certain risk factor, overall risk factor of remoteness on any projects that we have on any of the in our portfolio around any of these camps, basically, as they call it, mining camps. Ring of Fire is the one that is getting developed right now, and it's quite remote. So you can kind of come up with some established quantitative measure of difference between these in terms of remoteness risk. This is the same map for northern BC and Alberta within Canada. This is Fort McMurray, where there is and Grand Prairie, where there is a whole lot of like oil sands activities going on, and we can see that our index actually quite interestingly collected those. And just to finish my presentation, thank you very much for the chance. We do believe that this was an interesting way of quite with low cost, rather, quantify remoteness or things to that nature. And we do believe that it has definitely applications in risk management, but as well in resilience planning for remote communities and within policy making, as it is established with the Nighttime Lights application, I believe, in many of these areas. We proposed our index to Statistics Canada as well, and we hope that as more VIRS readings or data come online, we can establish that our index basically annually going forward. With that, I just want to say thank you again, and I'd be very happy to answer any questions. And if there would be need, I can be reached out at my email.